for part 3, and we're going to start off with a nearshore zone. So as you can see in the figure on the bottom, the nearshore zone is the upper limit of the shoreline to just beyond the area of the breaking wave. It contains the breaker zone of the breaking wave, and it also contains the surf zone that you can see shown on the bottom of this figure. Surf zone is that zone where the water from the breaking wave is going to move back and forth. Now we do find two types of currents in the nearshore zone. First off, we have our longshore current, and that is the current that results from wave refraction that's found between the breaker zone and a beach that flows parallel to the shoreline. So wave refraction is the bending of the waves, and they bend so that they move nearly parallel to the shoreline. That slight angle of waves reaching the shore causes the longshore currents. Longshore current is particularly important in transporting and depositing the sediment in the near shore. This picture shows wave refraction, and you can see how the waves are refracted as they enter the shallow water, and they move nearly parallel to the shoreline. The second type of current we have is our rip current, and the rip current is a narrow surface current that flows out to sea through the breaker zone. So water that reaches the shore from the waves have to return to the sea. They are fed by longshore currents. The best way to get out of a rip current is to swim parallel to the shore. You can see by the picture that we have, this picture which is A, you can see that the rip currents are fed on each side by currents that are moving parallel to the shore, as I stated. And in this picture B shows how you can distinguish a rip current, and that is by the cloudy nature, and that is because of the suspended particles. Rip currents move very fast, and they move perpendicular to the shore. This top picture kind of tells you what to do if you get caught in a rip current. So you can see how they're moving perpendicular to the shoreline. Your means of escaping is to try to swim horizontal, parallel to the shore, to escape that rip current. Now, some features of shoreline erosion that we see. Most of our shoreline erosion is going to come from waves, and our first feature is what we call a sea cliff. It is a steep and vertical slope. It is eroded during storms by waves and abrasion by sand and gravel. The picture on the left shows how your rocks in the lower portion have been eroded by abrasion, and they're very smooth, where the rocks on the top have not been abraded because they're out of the reach of your waves. The picture on the right shows the hydraulic action and abrasion, how we've undercut these sea cliffs in California, and the erosion was very intense that basically the home slid down the cliff. Another feature of erosion is our wave-cut platform. So a wave-cut platform, as you can see in the picture on the left, is a beveled surface that slopes gently seaward. It is formed by the erosion and retreat of a sea cliff. We could also get a marine terrace being formed, and that is simply a wave-cut platform that's uplifted to above sea level. A wave-built platform, as shown on the picture in the left side, is when you have deposition at the seaward margin of your wave-cut platform. The picture on the right of this slide shows your marine terraces, and they also show a very large sea stack. This is our sea stack that I've circled. This picture is taken from West Iceland. Now, some other features of erosion, we have the headlands that you can see in the diagram. That is part of your shoreline that's commonly bounded by cliffs, and it extends out into the sea or the lake. They are going to be eroded on both sides by wave refraction. You can see your sea cave that is on the opposite side of a headland. The sea arch that you see in this diagram forms when sea caves join. The sea stack is formed when you have continued erosion and the arch basically collapses. Now, erosion will be concentrated at the headlands, and eventually what's going to happen is it's going to straighten your irregular shorelines. So in some of these pictures, in picture A, the picture we've seen in the previous slide, in picture B, you see the nice archway in the Tasman National Park in Australia. And in picture C, you see the sea stacks in a beach in Washington State. This ends part 3 of Chapter 15.